Okay, so same functions. We're going to do g of f of x. I always say write the g of x rule above where you write g of f of x until you really get used to that. After you've done 100 composites and you think you can do without doing that, go ahead. But don't rush it. It doesn't take long to write it down to be sure you're looking at it right. Okay, so the x has been replaced by f of x. So we're going to replace the x over here by f of x. So you're going to have the square root of f of x minus 3, right? And now f of x, as you know, is your x squared plus 4. Okay? And that's then square root of x squared plus 1. Any restrictions?
What?
Any restrictions on your domain?
It has to be greater than or equal to 1.
For this one, yeah. But up here, you have a restriction because g of x is restricted. And really, I didn't want to confuse the issue by writing it here, but I brought it up over here, so I'm going to say, we write any restriction on g of x here. Okay? So whatever you plug in for x has to be greater than or equal to 3, right?
Right.
Which means that, over a little, f of x has to be greater than or equal to 3 if you're going to plug it in to g of x, right?
Right.
Of course, x squared is f of x is x squared plus 4, which is always greater than or equal to 4. So it's certainly greater than or equal to 3. So it's okay since x squared plus 4, which is f of x, is always greater than or equal to 4. So we don't have a restriction. Any x will work because there's no x that makes f of x less than 3, right?
Right.
And it worked out that way anyhow. So there's no restriction on the domain. But the whole thing about the domain and the range of this thing is a little bit tricky. It's sometimes hard to even understand what the point of it is, okay? But believe me, there is one.